everybody. I'm Michael Heldebrant, a distinguished solution architect with Elastic. I'm here to do a small video refresher on my chunking blog. For those that remember the chunking large documents blog that was published to Search Labs, um, and hopefully you remember my original icon here, or the image that we put in there. Uh, I've got an update on it, and I thought I'd share with you today. So let me pull up my screen for you. So here is the original blog. And for those that followed along, it started off with a pretty simplistic script to be able to split things up based on sentences with a tiny bit of intelligence to try and avoid things like Mr. and Mrs. and Miss and things like that. But that was a level one approach for chunking, which is known as fixed size chunking. I've gone ahead and up-leveled it to a level 2 and actually implemented a recursive chunking strategy. And so what I want to show you today is how that looks and how much better it is actually at breaking up documents into chunks. And to prove my point, I'm going to show you some latest work in the field, and how do you get the best practices in retrieval augmented generation, and somewhere in here is chunking is a discussion of that. And so what I want to show you though is that how easy it is to go get things like a big pile of PDFs, and if you try and ask a PDF the question that you have, what is a balanced chunking strategy, you can see that it doesn't work. It's actually very frustrating. The PDF does not contain that phrase. And then you can do things like, well, chunking, and then you're like, oh, there's 17 hits. It's only 22 pages, so chunking is basically one per page on average almost. And so that forces you to read the whole darn document. But using, you can use whatever you want to load things, but if you're looking for something nice and easy, I'm going to point you to one of my colleagues, David. He put together FSCrawler, and FSCrawler allows you to basically harness the power of Apache Tika and Elasticsearch to be able to process things like a pile of PDFs or anything just lying around your computer, or if you're an enterprise, you can just load anything you can get your hands on that's PDF. And so what I'm going to do is show you what that looks like. And so, there's nothing up my sleeve. There's no, the job name is the one that I'm going to put the document in. And so you're going to see that doesn't exist right now. I'm going to quickly go ahead and run it. And in just a second, it's going to load that PDF and index it to Elasticsearch as soon as it starts up. Let's give it 1 second. Oh, sorry, I forgot to update a timestamp. Excuse me. Again, it's intelligent enough to not re-index documents that you've already indexed. And so in just a moment, there we go. The index is there, and boom, we've already got that whole PDF loaded. Again, Elasticsearch is really good at being able to put that whole PDF in. And, we can always ask our same question again of, hey, is there a balanced chunking strategy? No, it's the same problem because, it's not semantically searchable. It's still lexically searchable. And you could look for things there if you know exactly what you're looking for. But let's go ahead and delete on the index that I'm going to show you what we're going to work on. So again, nothing up my sleeve. There's nothing in here. If you follow the blog, same general idea. I'm using the E5 model this time to be able to do the dense vector representation of this. And so I'm just going to go ahead and set some mappings in here. The mappings are here, and a couple of things on rules of thumb. And again, I write simple scripts. This should get the job done. You can get 512 tokens in this particular model. And so, it's about 2,048 characters. This is the max. And so this script I set to be pretty conservative. It does about 1,500 characters of data, which is actually a lot more than you think. This will get published in the very near future, but this is the improved version of the script where now it basically recursively starts with whole paragraphs if they fit. If the paragraph doesn't, it'll move to the sentence level. If the sentence level doesn't work, we might need to split in the middle of the sentence. And then if you've got some sort of giant word that stretches on forever, German language is notorious for having things with no spaces, for example, it'll just eventually give up and chop a word in the middle because, having the chop there is better than basically overrunning the token limits or having no chance to do it. But again, it's always going to look to see if it can move backwards or forwards to see if it can actually break on some sort of, English separator of the tokens here. And so this is tunable. So again, if you want to play with it to your heart's content, you can go up or down. The long word is, figuring out how long of a word it is before we give up on it. And you can set your own delimiters. So again, we're breaking on new lines and we're, splitting words on spaces, for example. The content field is where we're going to put that. And here is the for each processor that once we have this chunked up document, it's going to go ahead and run the E5 model on each of those. So if we put the pipeline in and I run a quick reindex, again, this is the one document, and we're going to go ahead and put it in the index that we just prepped with that new chunker pipeline. You're going to see how fast it is. We're done already. We chunked all of those things already. And let me show you what it looks like now. So just to show you, I have a quick aggregation to get the max number of chunks. And so it tore this 22-page document of a PDF into about 54 different chunks in there. And so if you actually go and look at them, you can see that it's got good chunks of text. And so here we've got the first part of the document, searching for best practices. That ends the first chunk. Look at that. It's wonderful to write on a paragraph. We started the next section on introduction, and then you see all this weird stuff and you realize, oh, that's right. In some PDFs, again, what it did is it took the text out of that. Tika did its job because these are actually words. But again, you'd need a more advanced PDF extractor to be able to try and get this as images and things like that. Not the purpose of this particular chunker. It's just going to grab the text so that you can work with it in some way, shape, or form. And so I want you to notice here that, you get all the way to that after we've parsed what was in the image and retrieve a source. It starts with here again. And this again is a kind of an artifact of how the PDF was put together. Here's this figure in the middle of it, and you can see that, these things are connected to each other, but this is in the middle. So again, hint, hint, as I continue to work, there'll be this concept of a level 3 one of these days where I get to full document-based chunking, but that's going to require some sort of cooperation between publishers of, giving me the document model, or if you're going to build this up and do it at a professional or an enterprise level, this is obviously the right place to go so you don't have to chase things around like this, but this is still so much better than trying to search the PDF yourself, because you can now do things with this giant document. You can ask it, oh, what is a balanced chunking strategy? And now we have, a max score of 0.91. So we found something pretty good. Talks about post-processing, breaking into chunks, small chunks. So it's talking about chunking in here. And, you're always going to want to get probably more than one hit. So this one's basically tied right up at a 0.917 versus 0.9178, for example. This second one does give me exactly what I wanted to. So I didn't have to read all 22 pages or all 54 chunks. I can see right here, I only had to scan the first 2 hits to be able to find the answer to the question of, what's a balanced chunking strategy? And for these particular authors, they did it at the sentence level. And so hopefully this is, very exciting for you to see, because it really doesn't take long to parse, even 500-page PDFs this way. The amount of speed you can get in going from a raw document to having it loaded and indexed and having it semantically searchable with the power and capabilities of Elasticsearch is pretty easy. So with that, thank you for your attention, and I hope you have a great day.